Exploring Sri Lanka's hydraulic civilization. Unveiling traditional hydraulic engineering principles used in a transboundary water diversion through a single Bund canal system. The single Bund canal system may have similarities to other traditional irrigation methods in different parts of the world. Its specific design and application are more inherent to regions like Sri Lanka, where it has been historically practiced as an effective means of directing and managing water.
Paddy farming has deep historical roots within the Sri Lankan community, being traditionally cultivated across various regions of the country, particularly in low-lying areas. Basically, natural drainage patterns were used in developing most of the traditional irrigation technologies. Video shows the highlands and adjoining paddy lands. Land boundary is clearly visible where most of the irrigation canals are located along these land boundaries and fetch water along these canals towards lower elevations. Water drains from the adjoining highlands accumulate at the foot of these hilly areas and naturally run downstream, creating natural drainage lines, and finally meeting nearby streams or tributaries. These natural waterways were used to design these single Bund canal systems. Generally, this canal system could be seen almost all parts of the country. This principle was used to build more larger canal systems, even for transboundary water diversions, known as Yoda Ella, or giant canal system. One such, Yod Ella, or giant canal was constructed to divert water from Kalawiwa Reservoir in the Kalaoya Basin to a reservoir named Thisawiwa in the Mawathu Oya Basin. The Yoda Ella originates from Kalawiwa and runs along the right side of the Kalaoya Basin boundary towards the Mawathu Oya Basin. It follows the lowest achievable elevation along its chosen route. The shaded area on the map, along with the short arrowheads pointing towards the Yoda Ella, represents the drainage region where water flows from the adjacent hilly areas on the right side of the Kalaoya Basin. Passing the Kalaoya Basin, Yoda Ella enters into the very upstream of the Madaraga Maru Basin and flows into the Mawathu Oya Basin. Drainage areas of the Yoda Ella within the Mawathu Oya Basin is at the left side of the Yoda Ella. According to local belief, the selection of the Yoda Ella's pathway was guided by the behavior of a pregnant goat. Pregnant goats typically choose the safest route to descend from hilly areas, and this behavior was utilized to determine the path with the lowest possible elevation for the canal. The Yoda Ella exemplifies the ingenuity of ancient Sri Lankan civilizations in harnessing water resources and practicing transboundary diversion of irrigation water for many thousand years ago, for agricultural and societal development. It stands as a testament to the mastery of irrigation and engineering techniques that were employed to create sustainable systems for water distribution and management.
This clearly depicts the Yoda Ella and its encompassing area. The neighboring highlands serve as the drainage area for the Yoda Ella. As previously discussed in this video, the Yoda Ella unmistakably adheres to the natural drainage line, running alongside the base of the hilly region. Constructing a single Bund at the paddy field end is fair enough to divert water from upstream to downstream areas.
Size and length. The Yoda Ella is notably large in size, having length of 87 kilometers, and consisting meandering route. Although it has a low flow rate, water is radially accelerating along with meanders while being subjected to deflect and deformed along the whole stream, giving steady but sluggish flow. Yi has been built to follow outstanding gradients vary from 10 to 20 centimeters per kilometer. It is collecting water from 66 mini catchments, whereas it fed water to about 120 small lakes along its length. In many respects, it is akin to an elongated reservoir because of the single embankment and extends over a considerable distance. It covers a long stretch of land, showcasing the advanced engineering capabilities of the ancient Sri Lankan civilization. Size and length. The Yoda Ella is notably large in size, having length of 87 kilometers, and consisting meandering route. Although it has a low flow rate, water is radially accelerating along with meanders while being subjected to deflect and deformed along the whole stream, giving steady but sluggish flow. Yi has been built to follow outstanding gradients vary from 10 to 20 centimeters per kilometer. It is collecting water from 66 mini catchments, whereas it fed water to about 120 small size and length. The Yoda Ella is notably large in size, having length of 87 kilometers, and consisting meandering route. Although it has a low flow rate, Water is radially accelerating along with meanders while being subjected to deflect and deformed along the whole stream, giving steady but sluggish flow. Yi has been built to follow outstanding gradients vary from 10 to 20 centimeters per kilometer. It is collecting water from 66 mini catchments, whereas it fed water to about 120 small lakes along its length. In many respects, it is akin to an elongated reservoir because of the single embankment and extends over a considerable distance. It covers a long stretch of land, showcasing the advanced engineering capabilities of the ancient Sri Lankan civilization. Stone construction. The canal's construction features the use of well-cut stones and well-laid masonry, indicating a high level of craftsmanship and engineering skill of the time. Gradient control. The canal is designed with a gentle gradient to ensure the controlled flow of water from the higher Kala Wiwa Reservoir to the lower Tissa Wiwa Reservoir. This gradient control was essential for preventing excessive erosion and ensuring even water distribution. Water regulation structures. Along the length of the canal, there are likely to be various water regulation structures such as sluice gates, weirs, and bunds. These structures allowed for the management and control of water flow, ensuring efficient distribution to fields, and preventing water wastage. Sediment management. The canal might incorporate features to manage sediment accumulation, preventing it from clogging the canal and maintaining its efficiency over time. Hydraulic engineering. The Yoda Law showcases an understanding of hydraulic principles, as evidenced by its design for controlled water movement between the two reservoirs. Cultural significance. The Yoda Law, or Giant Canal, was constructed during the reign of King Datusena, 455–473 AD, in ancient Sri Lanka. The Yoda Law is not only an engineering marvel but also holds cultural and historical significance. It reflects the advanced engineering achievements of ancient Sri Lanka and highlights the importance of water management in sustaining agriculture and society. In 2007, the construction of the new Jaya Ganga took place upstream from the existing Yoda Law. Utilizing modern engineering techniques, the meandering path of the original Yoda Law was replaced with a straighter and deeper canal alignment. This alteration exposed deeper soil layers to the water flow, resulting in a decline in water quality due to the release of contaminants from these layers. This situation highlights the advanced understanding ancient hydraulic engineers possessed concerning the complex relationship between subsurface soil layers and their effects on water quality in the canal.